Hello viewers, you're welcome to SciX channel, and today we'll be looking at limits by simplification, which is one of those methods of simplifying or evaluating limits rather. So we'll be looking at this method today. The method of simplifying limits is a very powerful method. It's actually your next resolve when the method of direct substitution fails. And how do we go about this method of simplifying limits? It's either by factorization or by rationalizing the function. So we want to see how this works. So with the given equations on the board, let's see how we do this. Okay, for question number 1, we have the limit of x approaches 10, x squared minus 100 divided by x minus 10. So let's see. Remember, your first resolve to evaluate any limit is by direct substitution. So we have to just plug it in and see what's going to be the outcome. So we decide the method to use from there. So if x is approaching 10 for the function, let's see. So this will be for x, we'll put 10, right? Because x approaches 10. So this becomes 100, 10 squared rather, minus 100 divided by 10 minus 10, right? So 10 squared is 100, 100 minus 100 is 0. So you have 0 divided by 10 minus 10 is what? 0. This is actually one of the indeterminates that I did make mention of in the last class. So in that we have encountered one of these indeterminates, we have to move to the next method. And your next result, like I said, is by the method of simplification. But how do I know if I'm rationalizing or if I'm using factorization? It has to do, it's solely dependent on the function I'm dealing with. If it's radicals with roots, then you know that you're going to use rationalization, like the right hand side of my board. And then if it's just polynomials, things that is factorizable, then you use the factorization method. So let's solve question number 1. I have the limit as x approaches 10 for x squared minus 100 divided by x minus 10, right? So let's factorize and see. Is this factorizable? Yes. X squared minus 100 is what you call difference of 2 squared, because 100 is actually 10 squared. So you have difference of 2 squares, a square and a square, right? So how do you factorize that? This will be equal to x plus 10, x minus 10, difference of 2 squared, right, divided by x minus 10. Now, this is x minus 10, x minus 10, so there you can cancel out. What you're left with is what? You're left with the limit as x approaches 10, and our function is x plus 10. So for x, you put 10, right? So this becomes x, this becomes 10 plus 10, which is equal to what? 20, exactly. So that's how you evaluate using factorization method. Let's try question number 2 together, but I'll give you a little time to, take a note, go through it, and ask your questions. All right, so let's continue with question number 2. So I'm rubbing this part off. Okay, so for question number 2, we have the limit for 2x squared minus 7x minus 15 divided by x minus 5 as x approaches 5. So let's substitute. If you substitute x for 5, then you get 5 squared is 25. 25 times 2, that's 50, minus 7 times 5 is 35, minus 15, all divided by 5 minus 5, that's 5x, 5 minus 5. Of course, 50 minus 35 will give you 15. 15 minus 15 gives you 0. 5 minus 5 gives you 0. So you have the same case of indeterminate as the first one. 0 divide by 0. And in that case, we are going to move to method of simplification, specifically by factorization method, because this is actually a polynomial, right? Okay, so let's go through it together. The limit as x approaches 5 for 2x squared minus 7x minus 15 as x minus 5. Okay, so let's see if we can factorize this. Is it possible to factorize this? Let's see. 2 times minus 15 will give us minus 30. So now we are going to look for two numbers such that if we multiply it, it will give us minus 30, and if we add those two numbers, it will give us minus 7. What do you think those numbers are? Yes, 10 and 3. 10 and 3. But how do we put signs on them? 10 and 3. So 10 times 3 is 30, right? But then we need minus 30. We want to produce minus 30. So one of them has to carry a negative sign, right? But which of them needs to carry the negative sign such that if you add the two of them, it will give you minus 7? You're right. 10 is supposed to carry the negative sign. So what you have is minus 10 and 3. Those are the two numbers to use for the factorization. So this brings us to the limit as x approaches 5 into 2x minus 10, 2x plus 3 divided by x minus 5. Yes, you are probably wondering, this does not look like anything that can cancel out. But can you see that from here, you can factorize, you can bring out 2 from there. Yes, so we now have, if we bring out 2 from here, we are going to have the limit as x approaches 5, 2 into x minus 5, 2x plus 3 divided by x minus 5. Of course, at this point, x minus 5 and x minus 5 can cancel out. And then you are left with, cleaning this, and then you're left with what? The limit as x approaches 5. This goes out, this goes out. For 2x plus 3. Yes, at this point, you can simply do direct substitution. So let's plug in the value of x, which is 5. So this will be equal to 2 into 2 times 5 is 10. So 10 plus 3. This is equal to 10 plus 3 is 13. 13 multiplied by 2, and then you have 26. So this is the answer to the question. So this is the limit of the function we talk about as x approaches what? 5. Now, if in cases where you have the function as with square roots, with radicands, then you can actually not be able to use the factorization method because you cannot factorize such function. So we'll have to use rationalization. So let's see question number 3 and question number 4, how we can be able to do that. Of course, when you are dealing with simplification by rationalization, your first result is always conjugates. You actually need to take the conjugation of the function you're dealing with. But let's see, x approaches minus 2. So if I substitute this, it becomes minus 2 plus 2, which is 0, right? And then from the denominator, minus 2 plus 4 will give us what? 4. Sorry, minus 2 plus 6 will give us 4. And the square root of 4 is what? 2. 2 minus 2 is what? 0. So you're left with 0 over 0, which means direct substitution could not actually resolve that limit. And that's why we are going to be needing what? Rationalization. But what are we rationalizing in this case? We are rationalizing the denominator. Why? Because it's the denominator that carries the radicand sign. So we'll be rationalizing the denominator. So what does it mean to rationalize? All you need to do is to multiply both numerator and denominator by the conjugate of what you want to rationalize, right? by the conjugate. What I mean by conjugate, just the difference in sign. Okay, the sign alternation. So this will be the limit as x approaches -2 of x plus 2 divided by x plus 6 square root of x plus 6 minus 2 times x plus 6 plus 2 divide root x plus 6 plus 2. Of course, it's as though we never did anything to the expression, because this divided by this is 1, so multiplying anything by 1 remains itself, but then it can go a long way to help us to do what we want to do. So how do we go about this? You may be tempted to multiply or take the product of the numerator. Yes, which is nothing wrong in doing that, but then it's actually a pitfall when you're dealing with rationalization. So what you need to do is, every time you want to rationalize, you only take the product of what actually guarantees you to do the rationalization in the first place. What prompted the rationalization in the first place is what you're going to take the product. Of course, what made us to rationalize here is the denominator. So in this place, we have to take the product of the denominator. Do not take the product of the numerator. If it's in a case where you're rationalizing the numerator, then take the product of what actually caused the rationalization in the first place, right? So here we go. If we take this, we are going to have the limit as x approaches -2 for x plus 2 multiplied by square root of x plus 6 plus 2. Okay, so let's take this. We are going to be multiplying this. It's like having two brackets, right? For example, you're having a plus b, a minus b. So taking expansion, normal expansion. So let's do that. Square root of x plus 6 multiplied by square root of x plus 6. That will just be square root of x plus 6 squared. And of course, your squared will take off your square root. So you're left with x plus 6. X plus 6. Now, square root of x plus 6 multiplied by 2 will give us plus 2 square root of x plus 6. Okay, now multiplying with -2. -2 times square root of x plus 6 will give you -2 times square root of x plus 6. And then lastly, -2 times 2. That will give you -4. So this is -4. Okay, now let's move a step further. So this is the limit of x approaches -2. Of course, 2 root x plus 6 minus 2 root x plus 6 will give us what? 0. That's correct. And then we'll have what? X plus 6, x plus 2 into square root of x plus 6 plus 2 divided by, this is 0. So we are left with x plus 6 minus 4. 6 minus 4, 2. So this is x plus 2 as my denominator. X plus 2. Of course, this can cancel out, right? It can cancel out. So let me continue that from this part of the board. I'm going to continue this from this other part of the board. So this can cancel out, and I'm left with limit as x approaches -2 for square root of x plus 6 plus 2. And for my x approaches -2, this becomes square root of -2 plus 6 plus 2. This is equal to -2 plus 6 is 4. Square root of 4 is 2. So this is 2 plus 2, and this is equal to 4. Yeah, and this is how you rationalize your denominator. And for case the next question, which is question number 4, you can see that the radicand is on my numerator. So it means I'll be rationalizing the numerator, which is something you're not very familiar of. we are more familiar about rationalizing the denominator. Yes, as much as you do to the denominator, you can also do to the numerator. Let's see how it goes then. So for question number 4, I'm going to rub my board, of course. I'm going to rub my board. Okay, I'm sure you've taken down that part. If you've not, you can go back again and pause the video. Okay, for question number 4, the limit of 2 minus square root of x all divided by 4x minus x squared. So let's see, for x approaching 4, this is 2 minus square root of 4, which is 2 minus square root of 4 is 2. So 2 minus 2 is 0, right? My numerator is already 0. And then let's substitute for 4 again. 4 times 4 is what? 16. X squared, which is 4 squared, is still 16. So 16 minus 16 is 0. This is the same kind of indeterminate, right? Okay, we go to looking at it from rationalization. I'm going to be rationalizing my numerator because that's where my problem comes from. So this is 2 minus square root of x divide 4x minus x squared times 2 plus square root of x divided by 2 plus square root of x. Okay, so we said where what actually prompts the rationalization is where you make your multiplication, and the place that do not, you leave it. So I'm going to be multiplying the numerator, and what I will get, this will be limit as x approaches 4. 2 times 2 is 4, and 2 times root x, that's plus 2 root x, minus root x times 2 will give me minus 2 root x, and then root x times root x will give me x, but I have my minus sign here, so this is minus x, all divided by 4x minus x squared 2 plus root x plus 2 root x minus 2 root x will give me 0. So I'm left with 4 minus x. 4 minus x. So this is the limit as x approaches 4. Here is 4 minus x. That's what I'm left with. But then from the denominator, I can factor out x here, and I get x, 4 minus x, and then this is 2 plus root x, right? So 4 minus x can cancel out, and then you have this. So you're left with, this will be equal to the limit as x approaches 4 for the function 1 divided by x into 2 plus root x. So all we need to do is to just substitute the value of x for 4, and then we get our last answer. So what would that be? This is 4 and this is root 4. Root 4 is equal to 2, so 2 plus 4 is 4. 4 times 4 is 16. So finally our answer is going to be 1 all over 16. That's our final answer. So I would want to leave you with questions, 1 or 2, so that you can try it yourself. But this is how it works to evaluate by simplification method. You've seen it. So I'll be leaving you with these questions. Just in your free time, try them. The limit as x approaches 1 for x cubed minus 1 divided by x minus 1. And lastly, the limit as x approaches 8 for the cube root of x minus 2 divided by x minus 8. So try these questions, and then when we come back later, we'll know whether or not we were correct. So up until I come your way, like, comment, subscribe, and do not forget to hit the notification button so when next videos are dropped you get to see my videos. Thank you.